like. So let's create a mental image of this skill set. So if I say data scientist, what do they need? So for someone to become a full stack data scientist, they need a combination of three things. First is what I call as tooling. Second thing, what I call as domain knowledge. Okay. And third is business expertise. Okay. So what I understood, you guys are already having some understanding of various kind of tooling. So in the upcoming sessions, what I'll be focusing on giving you the domain knowledge and then building on business expertise. So let's understand what does these mean. Okay. So when I talk about tooling, I am talking about something like SQL scripting, Python, and when I say Python, mostly pandas. Then we talk about visualization tools like Tableau, Power BI. Similarly, when I talk about domain knowledge, here I'm talking about stats, and I'm talking about machine learning. Business expertise is something which we will deal with the topics later, but mostly you could become like a product data scientist, you could be a product DS, you could become a marketing DS, you could be an operations data scientist. So what is required for these kinds of data scientists? And we will learn through various case studies that how to excel in various business expertise. Okay. So with this overview, now let's quickly jump a bit into what comes, like what are the topics I would be covering in domain knowledge. Okay. So like I said, in domain knowledge, we would be primarily talking about two kinds of topics. First is what I call as stats. So stats also have two dimensions. First one in the stats is called descriptive stats. Second is inferential stats. Okay. So let's understand what does these mean. Okay. Just give me a second, guys. Okay, so let's understand what does descriptive means. So descriptive means, or let's take a step first. First, let's understand how does our data look. So mostly we get something called a tabular data. Okay. So let's take I take a very simple example of gym. So let's say I have data for 1,000 users of a gym. So if I'm collecting this data, 1, 2, 3, up to 1,000. Okay. Then let's say I have height. Let's say I'm saying somebody is 160 centimeters, the person is 170 centimeters, this is 178, this person is 152. Then I can have weight. Okay. Then let's say I have 55 kg, 75 kg, 100 kg, 43 kg. Okay. Then exercise type. Let's say this person is just doing cardio, this person is just doing weight, this person is doing cardio plus weight, and so on. And month on month, change in weight. Okay, let's say this person gained 2 kg, this person lost 5 kg, this person lost 15 kg, this person gained 1 kg. Something like a data set. So most of the time in real world, you would be given a data set like this. And then your stakeholders, like it could be your product manager, it could be your sales team, it could be anyone. They will come to you, hey, can you look at this data and tell us some interesting things? Okay, what is interesting? What should you tell? We don't know. And that is where we apply our knowledge of stats. Where we cover concept on descriptive and inferential. Okay. So what does descriptive stats do here? So descriptive stats help to create summaries of the data set. So what do I mean by summary? Things like what is the number of clients? What is average weight? What is average height? Something like this. So did you see? I started using certain terminology here. I talked about number. I talked about average. I talked about average. So if somebody asks, hey, can you create summary of this? You can't just go and give them this entire data set. You have to think about what can I show in summary. So any part of mathematics which helps you to understand what can you show in summary, what are you have available, what are the kind of data cuts you can do in summary, that is all descriptive steps, where you are describing a data set with a specific number. The second part we call as is inferential stats. Okay? So inferential stats helps you to draw conclusion or develop some inferences, takeaways. Okay? So something like, if we saw somebody who is doing cardio, their weight changes by, let's say, 3 kgs. Somebody who is doing weight training, somebody who's doing cardio, they lose weight by 3 kg. Somebody who's doing weight training, they gain 2 kgs weight. Whereas somebody is doing cardio plus weight, they are actually losing 2 kg, but they are gaining, let's say, 2 kg of muscle. So what you can give as an inference, what if your goal is just to lose weight, you should focus on cardio. If your goal is to just gain weight, then you should focus more on weight training. However, if your goal is to gain muscle and lose fat, lose weight, you can do a combination of both. So when you start making these kind of inferences from the data, it comes under inferential stats. Okay? Sounds fair? Perfect. Then the third part of the stats, which we call as machine learning, like our most beloved topic, machine learning, or as we call it ML, it helps you to make prediction. It helps you to make prediction about future. Okay? So something like, if I am going to gym daily, I am doing cardio plus weight, eating clean, how much weight loss can I expect, right? Or if I buy a house for 1 CR today, how much can I expect in 5 years? Yeah? Or if I say I want something for 100 million today, how much can I expect later? So these kind of predictions, when you are making, this is called machine learning. Or if you guys see, whenever you are taking a loan or you are taking a credit card, they ask you for KYC or any kind of verification, right? And then they say whether they can allow you a SIM or not, allow you a loan or not, allow you a credit card or not. What they do, they predict whether you are a fraud or not. If they predict that you are likely to be a fraud, they won't give you a loan or credit card. But if they predict, no, you are not a fraud, then they will give you. So all the part where you are looking into some data today and making a prediction about future, that comes into machine learning. So this is what comes under domain knowledge, which we would keep on learning in the next few sessions and be ready for our next data science. Okay? So this is like painting an overall picture. For today's session, we are going to strictly focus on descriptive stats. Okay. Now, few of you might feel, what, Ishan, this is very basic maths, maybe what I have studied in school. But your entire data science is actually your class 10th or up to class 12th mathematics. So data scientist is not, it's all basic high school maths. But we have to learn about applications of concept. And for strong application, you need very strong foundation. That is what we are going to focus on in today's session, on all upcoming sessions. Okay? Just give me a minute, I'll quickly get some water, and then we will continue. Okay? I'll keep on switching between notes, and I'm also using 2 screens, so if you feel sometimes alignment is not perfect, it's not like I'm looking elsewhere, I'm mostly mostly sharing of screens or reading content from one to another. Okay? So let's start understanding basics of descriptive data. So you are a data scientist, and generally you got like something like height and weight. So for different kind of data points, let's see how our data is looking. So somebody is very thin but very tall, maybe they look like this. Somebody who is very heavy as well as very heighted is looking like this. At points, this is how, if I take data about all of you. This is how your data distribution would be looking like, right? Now, if I ask you, can you represent this entire data with just one number? Okay, so think about this. This is my entire data set. Can you represent this entire data set with just one number? Can you do that? Can you find a number which is representative of the entire data set? Don't know? Heard of it? Never heard of it? So there is a part in statistics which actually help us to do that. We call it measure of central tendency. Okay? So let's break this term. You will see if I write measure of central tendency. So let's break it. There is two keywords. One is measure and central tendency. Okay. So if you guys own a car, nobody asks you how old is your car or how many kilometers you drive. They were like, okay, can you tell me like how many kilometers it has ridden so far, or maybe what is the average of this car, right? Or when we go for our school, we are asked like, oh, what's your percentage, right? Did you get like top division, bottom division? So all we are looking for a single number which can represent this entire data. That is called, so when you are asking for a number which can represent the entire data, what you are looking for? You are looking for a central tendency. One number that can represent the entire data. And process of measuring central tendency is done through descriptive. So we are having three techniques, three data points which actually help us to calculate this measure of central tendency. What are those? These are mean, which is average of all data points. Sorry for my bad handwriting. I'll try to make it easier to read. Second is median. What does median mean? It says middle value of your data set. And what is the third? Third one which we have here is, choose the color. We call it mode. Observation with highest frequency. Don't worry if all these are sounding like remote words or alien words. Don't worry. I'll go through multiple examples so that all of you got these concepts really well by the end of this session. Okay? So let's go deep dive, or let's deep dive into some examples. Okay? So let's say someone in our group today got a interview call from Google. Okay? From Google Data Science. Now, you know what, like this is our general tendency. How much can I earn in a Google Data Science job? We all get like curious about this thing. So how can you find it? Okay? So let's do a practical demonstration. So guys, there is this amazing website, levels.fyi. Okay? This website allows you to look into the salaries at various roles. So we will understand this. So for example, I got a job interview call from Google, and I want to understand how much salary can I expect. Okay? And what we did, we looked into Google salaries. And then what kind of role we are looking for? We are looking for something called data scientist. Let's see in this list, if I scroll down, if I scroll down, can you see I'm getting a data scientist? So I click on data scientist. Now you guys can play around with country if you want. Let's say if I choose India. Not sure if there's a lot of data points. But can you see there are, let's say I'm looking for a level 4 role. Can you see there are so many salaries? This person is level 4. Let me see if I can filter by level. Let's say I say mid 2 to 6 years. Okay? I got these many salaries. Can you see? If we look, let me see if I can annotate it. Yeah, I can annotate it. Can you look into these two examples? Two people, same location. Google, Bangalore, Karnataka, India. Almost very similar date. Same level One has 6 years experience, another person has 4 years experience. And can you look into their salary difference? One person is saying roughly 86,000 US dollars, which is like 60, 70 lakhs. The other person is saying 71,000 US dollars, which would be like 50, 60 lakhs. You guys can look into the conversion part. Similarly, if I go into these later values, can you see I have various kinds of salaries available for the same level? Now, how do I know what I'm going to expect as salary? That I have got multiple data points, right? So let's come back to our original example. Yeah. Same thing. If I plot like a number line here, which is Google salary. Okay. And then I looked into levels FYI. I got multiple salaries. Somebody is making salary here, somebody is making salary here, somebody is making salary here, somebody is here, and something like that. So how do I know what is my salary? Now, we just learned there's a tool in statistics which is called measure of central tendency. Measure of central tendency. Now, what happens in measure of central tendency? We look into all the data points available to us. Like data points are here. And now, out of these 6 data points which I have here, these are the 6 data points I have. I have to find what? A single value, one single star which I have to find, which would be my approximate value of the salary I can expect from Google. How do we calculate this? Let's learn it. So, for the simplicity of the understanding, let's say I got 5 candidates: C1, C2, C3, C4, and C5, and they all are working for Google. And I was like, tell me your Google salary. Okay. Yeah. Let's remember this. This is all made up data, not real data. We are not allowed to ask anyone salary. So don't take this as like actual salaries. Okay. So let's say candidate one told you we are getting 30. Now it could be 30K USD, or you can call it 30 lakhs in India, whatever currency you want to pick. Similarly, C2 say another 30. You can use the currency. C3 said 35. C4 said 40, and C5 said 40. Okay. Now we got multiple points, and we have to see, okay, what could be my average salary? So the first technique which we are going to do is called mean. So how does mean says sum of all observation divided by total number of observations. Okay. And don't worry if you are feeling it's going a bit fast. I have very well written notes covering all these concepts. So don't worry, everything will be shared to you on notes as well. So let's learn. How do we calculate mean in this situation? What are the data points I have? I have 30 plus, and the person got 30, then 35 and 40 and 40, right? So 30, 35, 40, and how many observations I have? 5. Okay, so let's quickly sum it up. What would be the value we are getting? So 30 is 60, right? 60 plus 40 is 1. So total is 175 by 5. So the average value which I would be getting is like 35. So did you see what I did? I looked into What did I do? I looked into all the candidates, and then we got their salary 30, 35, 40. We took a summation of everything. So this summed up to 175, right? And how many observations I have? 5. So 175 divided by 5. So what is the average coming? 35. So you can say if I get an offer from Google, roughly my salary is going to be 35. Now you can keep it USD or lakhs or pounds, whatever you can see. This is a denominator, right? Okay, sounds good. I hope everyone is clear so far. Now, this is how we learned about getting a salary. Now, let's think about how many candidates we have? C1, C2, C3, C4, C5, and we have Google salary and calling it GS. It was 30, 35, 40. Now, let's say I added one more candidate, C6. And you know what this person said? The salary is 300. Wow. This is pretty high, right? Now you are thinking, how does this happen? This person could be an outlier, right? we might have done data collection error, data collection error. Or somebody was at a very high level, they mistakenly incorrect leveling. A combination of multiple things could have happened. But now we got like a very high value. Now what will happen if I calculate mean? What will happen if I calculate mean? If I calculate mean, we know the summation was till this point 175. So now when I look into sum of all observations, 175 plus 300. And now my data points are 6. Earlier I had 5. Now I got one more data point, which is 6. And the value is 300. So if I add all this, it is 475 by 6. You know what? Roughly my salary would be coming as 79. This is my mean. So what is my previous mean? It was 35. What is my new mean? 79. So more than twice. It is more than twice of the previous mean. Now, if I look into this data, I could be very confused. You know what? Now if I crack Google interview, I'll be getting 79 lakhs or 79,000 US dollars. I'll be rich. But is it true? Maybe not. Because the first 5 candidates have very low salary. And this 6th candidate sounds more like an outlier. Maybe the person negotiated really well, or by mistake we incorrectly collected the data. Something sounds fishy about it. Okay? So what kind of technique do we use when we get this kind of outlier data? Okay? When you get the outlier data, we use a technique called median. Okay? Now we use median when you have an outlier in your data. Okay? So let's go back. What did we learn about median? So here I have written what is the middle value of your data set. Okay? So now coming back to our data set, we have candidate 1, candidate 2, candidate 3, candidate 4, candidate 5, candidate 6. Okay? And then we have Google salary, which is 30, 35, 40, 79. So first thing we do is sort data into ascending order. Okay? In this situation, our data is already sorted into ascending order. Okay? Now, the second thing which we do is we take the middle value. Now, how many data points I have? 1, 2, 3, 4, 5, 6. Now, we have a situation, which one should we call as middle value? Should we call 3 or should we call 4? Because both lies in the middle. So the way we calculate median, so the rule for median calculation is, if total observations, we call it n. If total observation n is even, then you look into two values. What values you look? N by 2, n plus 1 by 2, and then you take average of this. What's this? If your n is odd, what you do? You took n plus 1 by 2 and that becomes your median. So let's understand this with an example. So in this situation, what is our n? N is equal to 6. N is equal to 6, which is even. Now what is n by 2? N by 2 is 6 by 2, which is 3. Sorry, there is a typo which I made while writing it. Let me just correct it. It is n by 2 plus 1. So what is my n by 2? 3. And what would be my n by 2 plus 1? It would be 6 by 2 plus 1, which is 4. So in this data set, what is my third term and what is my fourth term? It is coming as 35 plus 40 by 2, which is coming as 37.5. Okay? Now, whereas if you go to the previous data, when we have C1, C2, C3, C4, C5, what was the salaries? 30, 30, 35, 40, 40. Here n is equal to 5, which is odd. So what did we learn about? When n is odd, what value we take? 5 plus 1, n plus 1 by 2, which is third. So this will become your median value. Okay? So I hope With this, you all are clearly, you all are able to follow up when to go for median, when to go for mod. So let me just summarize it again. Summarize. Whenever you have to calculate measure of central tendency, summarize, measure of central tendency. Always start with mean. However, if you have outlier, switch to median. Now, you guys can ask Ishan, what is outlier? How do we identify if data has outlier or not? So don't worry, we will cover this as well. Okay? And now, let's jump into the third, which we call as mode. Now, what is mode? Mode, as I have listed earlier, it is observation with highest frequency. Okay? So let's understand this again with a data example. So let's say we have a data point. Okay? We have a data point which is like minus 90, 90, 90, 80, 90, 70, 95, and 90. Okay? So first thing which we will do here, we will find the unique observations. Okay? Unique observations. So let's say what all are the unique observations. Sorry, this is not minus 90. Again, I type it. So what are the unique observations I can see? I can see 90. I can see 80. I can also see 70. And I can also see 95. And now I'm going to count how many times each data is coming. So 90 is coming as 1, 2, 3, 4, and 5. So 90 is coming 5 times. How many times 80 is coming? 80 is coming 1 time. How many times 70 is coming? 70 is also coming 1 time. 95 is 80 coming. So what is the observation with the highest frequency? It is coming as 90. So 90 will become your mod. Okay? Sometimes there could also be 2 mods. That's possible. We call this kind of data as bimodal. Okay? Cool. So that is how we calculate. So let's do one thing, guys. Let's do a practice problem. Okay? Where we will calculate all the 3 things. So let's say we got a data set. We got a data set, which I'm defining as V, and we have values like 20, 30, 10, 60, 40, 80, 50, and 70. Okay? So we have total 8 data points, 20, 30, 10, 60, 40, 80, 50, and 70. Okay? Cool? Sounds good? Now, first thing we have to calculate is mean. How would we calculate? So mean is sum of all observation divided by total number of observation. So if I say how I'm going to write it, 10 plus 20 plus 30 plus 40 plus 50 plus 60 plus 70 plus 80 by 8. Okay? So if I have to calculate the sum of this, give me a second, let me just quickly calculate it. So a summation of all this would be coming as 360 by 8. Okay? Or it would be coming as 45. So the average value or the mean for this data set is 45. Okay? Now, if I calculate median, what I have to do? First thing I have to arrange this data into ascending order. So if I want to arrange it, how would it look? 10, 20, 30, 40, 50, 60, 70, 80. First thing is I arranged it in the ascending order. Second thing, n here is 8, which is even. So what would be n by 2? N by 2 would be 4th term. And what would be n by 2 plus 1? It is 5th term. So this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8. So what are my 4th and 5th terms? My fourth and fifth terms are these. Okay. So when I'm calculating the median, I'll be calculating fourth plus fifth by 2. So it is 40 plus 50 by 2 is equal to 45. Which is mean and median were simple. Now here if you see all the data points are coming only once, so kind of there is no mode. Okay. This should have clarified all the questions understanding with median, mode, mean, how do we calculate it. Okay. I hope everyone is clear. Someone asked that can you explain median again with an example, so I did it again. So I hope this should be okay. Let's do one more problem. Okay, let's do one more problem. So let's say I'm calling it problem number 2. So it's a pretty interesting one. So let's say you have 4 people. Okay, you have 4 people and they have age as average age or mean age as 24. So let's say I'm going to call these people. Let's not draw it. My drawing is horrible. Let's say I'm going to call them 1, 2, 3, 4. So the first person I know is of age 20. Second person I know is of age 28. Third person I do not know their age, so I'm going to call it X. And fourth one is 22. Now here what we have to do, we have to find the value of X. Okay. Here we have to find the value of X. Now how do we find it? So sorry. So we will solve it from the first principles. What does first principles like? Solving from the basic. So how do we calculate mean? Sum of all observations. Sum of all observations divided by total observations. So what is my mean coming? We already know the mean age of these 4 people is 24. So my mean is coming as 24. And what is my all observations? It is 20 plus 28 plus X is 22 divided by 4. So if I multiply 24 and 4, it would be 96. And if I take a summation of everything, it is 70 plus X. Right? So what is the value of X I am getting here? X is coming as 26. X is coming as 26. Now what do I have to do? I have to calculate the median age. So if I rewrite the data, what is 1, 2, 3, 4? 1 was here 20. Then 2 was 28. What is 3? 3 here is X. And what did we find? X is equal to 26. And what was 4? 4 was 22. So how do we calculate median? First we start with ascending order. So if I ascend it 20, 22, 26 and 28, right? So this value went to here. And this value came down to here. Now n is equal to 4. So you will calculate 4 by 2 and 4 by 2 plus 1 term, which is second and third term. And then we will take average of this. What would come as average? 22 plus 26 by 2, which is coming as 24. So 24 is coming as median age. Okay? So again, some people have doubt around how did this become X is 26. So I said that what was our problem statement? We have a group of 4 people. Person 1 has age of 20, person 2 has age of 28, person 3 we do not know their age, person 4 has age 22. Now what does mean means? Mean is equal to sum of all observations divided by total observations. How many observations we have here? We have 4. So denominator becomes 4. And what are your sum of all observations? It is 20 plus 28 plus X plus 22 divided by 4. So if you solve this equation, you will get X is equal to 26. Is this part clear now? Okay. Let's move on then. Let's move to the next part. Now we are going to learn another very interesting concept called weighted average. Okay. So let's recall the previous question, right? I said I have 4%, person 1, person 2, person 3, person 4, right? Person 1's age was 20, person 2 age was 20. Sorry. Person 2's age was 28, person 3 was X, which we determined as 26, and the last person by 22. And when somebody asked me, what is the average or mean age? What did I do? I did 20 plus 28 plus 26 plus 22 divided by 4. Okay? Which is coming as 24. That is how we calculated the mean. Right? But there are some situations in life. There are some situations in life which does not mean that all the observations are of equal weightage. Okay? So I'll go back to my college days. Right? So in college we have a concept of GPA. Okay? So GPA has two columns. Percentage. So when they were calculating my final GPA, what did they do, my college? What did they do? So they have semester, percentage marks I got, and then credits. So some semester has high credits, means it has more hours which we have to study, and some semester has low credits, which we have to give lower weightage. So for example, I did engineering. So in engineering, let's say there are 8 semesters. So first, second, third, fourth, fifth, sixth, seventh, eighth. Okay? Then let's say I got percentage. First semester I got 90% marks. In second semester I got 85. In the third semester again I got 90. In the fourth semester I did not study, so I got 80% marks. In fifth semester I got 87% marks. Then in the sixth semester I got, let's say 90. Seventh I got 88, and in the eighth semester I got 92. Now, if somebody asks me, okay, what is your average percentage in your engineering? I can't just take this number, right? Let's say if I put this into Google spreadsheet for a demonstration purpose. Let me just first put this number. Yeah, and then share the spreadsheet with all of you. Give me a second, guys. Let's creating this data. Okay, I hope everyone can see my screen. I'm increasing the size. So if you see, I'm talking about 8 semesters and I got these percentage marks, right? Now I can use this average formula. And I got 87.75%. But would it be a correct value? My answer is maybe not. Because we have one more thing called credits, which means how many credit each subject has taken. So if let's say each subject has got a credit like 50, right? Then I would have calculated every subject has equal weightage. Can you see whatever percentage I am getting, or in each semester I am having an equal credit of 50, 50, 50, 50. So this is all equal, right? But now reality was different. Reality was like my first semester was of 48 credit. My second semester was of 52 credit. My third semester was of 50 credit. My fourth semester was of 46 credits. Fifth one was again 51. Then sixth one was like 47. Eighth one was like 55. And last one was 53. Now, can you guys see a pattern? Wherever the credit is slightly high, like 52, 51, 55, I actually did slightly bad. I did not study very hard. Whereas I got high percentage in subjects with lower credits. So my actual percentage might come down. So let's calculate what is my actual percentage. Now I know my percentage in each, and I also know my credits. So what I'll do, I'll calculate a cumulative column. How would I calculate? Or I'm calling it combined, or weighted percentage. Okay, weighted percentage. So what happened is I would combine my percentage with the credits or weight and calculate a total value. Now I'll calculate a sum of this. Similarly, whatever weights I know, I calculate a sum of this. Now, when I am calculating the average, now this weighted percentage is my sum of all observations, and credit is going to be my total number of observations. So now my new mean or my weighted mean is going to be 37103 divided by 422. So can you see this number here, where all the subjects have equal weightage, versus this number where this subject has a higher weightage, was coming as different. Can you all see this? Understand the difference? So earlier we were assuming that every subject was having the same weight. So we take the average of, did the summation of all the percentage and divided by total number, which is 8. Here we first converted each percentage, multiplied percentage with credit to calculate the combined value, and then that combined value was divided by the combined value of the total credits. This is what we call as weighted average. Okay. Complex concept. Require more understanding. Okay. So let's do one more example. Just to simplify it and give more practical understanding. So let's say we are in a town which is called Town X. We live in a town called Town X. And now we are running a survey where we are asking people how many pets you have. Okay, how many pets you have. And let's say we survey 150 people. Okay. Now I am going to tell you number of pets and survey response. So in this survey, we went to each house and we asked them how many pets you have. So these were the possible combinations. We found that in none of the houses there were more than 3 pets. When we survey 150 people, 60 people say to us, you know what, we have 0 pets. What happened? The number of houses which said we have 1 pet was 50. Number of houses which say 2 pets was 30. And number of houses which say 3 pets is 20. Sorry. This is 10, not 20. Now, if somebody asks me, Ishan, what is the total number of pets, or what is the average number of pets we have in a house? So when I have to calculate, so what would be my average? Total number of pets divided by total number of houses. Now, how would I calculate total number of pets? So, how many houses have 0 pets? 60. So, 60 into 0 is 0. How many houses have 1 pet? 50 houses. How many pets? 1. So value is coming as 50. How many houses have 2 pets? 30 houses into 2 pets. So total number of houses 60. So total number of pets is 60. And how many houses have 3 pets? 10 houses into 3 pets, it is coming as 30. So what is my total number of pets? It is coming as 50 plus 60 plus 30. And how many houses we have? 150. So if I sum this, 140 by 150. This is the average number of pet per house. I hope with this calculation is now more clearer. I hope everyone is able to follow me. There is no questions, no confusions. Good. Guys, we are almost at the mid mark of the session. So let's take a 5-minute break and I'll be back after 5 minutes. Okay? So let me start the timer. You all can take some water break, bio break, whatever you need, and we will be back in 5 minutes.